Every object we hold has a story, stretching from cosmic origins to the palm of our hand. The metals in our smartphones were forged in ancient stars, mined from the earth, and transformed into the devices that power our lives. These gadgets become extensions of ourselves until they break, become obsolete, or are replaced. But their story doesn't end in a drawer or landfill. Instead, they join a vast, growing river of e-waste discarded technology flowing from homes and offices worldwide. This stream is rich in precious metals and critical elements, far more concentrated than natural ores. To bury it is to waste treasure and ignore the environmental cost of mining anew. Yet, within this challenge lies opportunity. With ingenuity, we can recover and reuse these materials, giving them new life. The journey from forgotten gadget to reborn resource is a cycle of technological alchemy, one that can power our world again and again. E-waste is anything with a plug, battery, or cord that's reached the end of its life: phones, laptops, fridges, even electric toothbrushes. Each year we generate a mountain of this waste, heavier than all commercial airliners ever built. Recycling is tough. Devices are complex, packed with over 60 elements, and often glued or sealed tight. Valuable metals like gold and palladium are mixed with toxic substances like lead and mercury. But e-waste is urban ore richer in precious metals than mined rock. Mining e-waste uses less energy and causes less harm than traditional mining. It's both a problem and a resource, highlighting the need to shift from a linear take, make, dispose model to a circular one. In a circular economy, waste becomes resource, and the end of one product is the beginning of another. Rethinking e-waste isn't just cleanup, it's a chance to transform our relationship with technology and the planet. The challenge is clear: innovate, take responsibility, and see value where others see trash. The first step in e-waste transformation is collection, getting old devices out of drawers and into the right hands. Accessible drop-off points, take-back programs, and special events make responsible disposal easy. But before recycling, ask, can this device be reused? Many gadgets are replaced, not broken. Refurbishing and repair can extend their lives, bridging the digital divide and saving resources. The hierarchy is clear: reduce, reuse, repair, then recycle. Only when a device is truly beyond repair should it be recycled, marking the start of its next life as raw material. Thoughtful choices slow the flow of waste and make the system more sustainable. Before recycling, data must be securely destroyed. Our devices hold our digital lives. Deleting files isn't enough. Specialized software overwrites storage multiple times, making recovery impossible. Damaged or high-security drives are physically shredded or degaussed, ensuring total data destruction. This process builds trust. Without it, people would hesitate to recycle, fearing data leaks. Only when the digital ghost is gone can recyclers safely reclaim materials. Secure data destruction is the foundation of responsible e-waste recycling. It ensures only raw materials, not memories, move on to the next stage. After data is wiped, hazardous parts must be removed, especially batteries, which can catch fire or explode if mishandled. Trained technicians carefully extract batteries, often glued in place, and send them to specialized recyclers. Other dangerous components like leaded glass, mercury lamps, and toxic capacitors are also removed by hand. This depollution protects workers, communities, and the environment from toxic exposure. Responsible recyclers prioritize safety, unlike informal operations that cause pollution and health crises. Careful removal of hazards is essential for ethical recycling. It's a slow, deliberate process that safeguards people and the planet. With hazards removed, devices are dismantled, sometimes by hand, increasingly by robots. Components like steel, plastic, and copper wiring are separated for cleaner recycling streams. Automation, using machine vision and robotics, is speeding up and improving this process. What remains is shredded into small fragments, breaking the bonds between materials. This technological confetti is ready for the next stage, precise separation. Shredding isn't just destruction, it's liberation, freeing valuable resources for recovery. The goal: turn complex products into pure, reusable materials. Shredded e-waste enters a high-tech sorting line, a mechanical ballet of magnets, eddy currents and sensors. Magnets pull out steel. Eddy current separators fling out aluminium and copper. Plastics are sorted by advanced sensors that identify each type by its unique light signature. Then air jets direct them into separate bins. Each stage purifies the stream, turning chaos into order. The result: piles of clean steel, aluminium, copper, and sorted plastics ready for new manufacturing. This cascade of separation is the heart of modern e-waste recycling. What began as a tangled device is now a set of valuable commodities. The journey from trash to resource is nearly complete. The real treasure in e-waste is in circuit boards packed with copper, gold, silver, and rare metals. Boards are sent to specialized smelters, where high temperatures and chemical processes separate and purify each metal. Gold, silver, and palladium are recovered at extraordinary purity, ready for reuse in new electronics. Rare earth magnets from motors and speakers are also targeted for recovery, reducing the need for new mining. Recycling these elements saves energy, cuts pollution, and secures critical resources for future tech. By reclaiming high-value materials, we create a strategic reserve for tomorrow's innovations. E-waste recycling isn't just waste management, it's resource stewardship. The final step is rebirth. Recovered materials become new products. Plastics are cleaned, melted, and formed into pellets for new casings and parts. Metals are melted and recast: steel for sheets, aluminium for frames, copper for wires. Precious metals return to the electronics industry, closing the loop. Quality and traceability are crucial. Recycled materials must meet strict standards. Blockchain and tracking systems ensure transparency from collection to new product. This cycle proves materials don't have to end in landfill. They can flow endlessly from product to product. Every recycled device is a step toward a smarter, more sustainable system. E-waste recycling is shaped by economics and ethics. High costs and volatile commodity prices make profitability a challenge, but policies like extended producer responsibility help. EPR laws require manufacturers to fund recycling, incentivizing better product design and shifting costs from taxpayers to producers. Ethical recycling means processing e-waste safely, not exporting pollution to poorer countries. Designing for circularity: modular, repairable, and recyclable products maximizes value and minimizes waste. A just circular economy values resources at every stage, from design to disposal. The future depends on making sustainability both profitable and fair. The journey from trash to tech depends on all of us. As consumers, we can buy less, repair more, and recycle responsibly. Businesses and designers must embrace circular principles: durability, repairability, and transparency. Innovations in recycling and AI promise even greater efficiency and recovery. Every device recycled is proof that a circular vision is possible now, not just in the future. We face a choice: continue wasting resources, or embrace the circle and value every material. The secret life of e-waste shows there is no a way, only a cycle we can guide for the good of all. Together, we can build a world where nothing is wasted, and everything has a second life.